One of the biggest problems with DeepSeek v4 was that it's text-only model, but seems like some users are getting access to the vision version. And now they also released a paper titled Thinking with Visual Primitives. And then it kind of disappeared. The headline numbers are genuinely wild. So for an 80 by 80 resolution image, this new model uses about 90 entries in its KV cache. In comparison, Sonnet 4.6 uses around 870, whereas Gemini 3 Flash uses 1100. That's almost 10 times less. So it seems like they have figured out how to create and serve extremely efficient vision models. So in this video, I want to do three things. First, I'll walk you through where this fits in DeepSeek's vision lineage, because this is not really a one-off paper. They have been telling the same story for 2 years now. Second, I'll explain the actual idea, which they call thinking with visual primitives, because it's a really clean concept once you see it. And third, we will look at the architecture, the benchmark numbers, and the limitations that they are not hiding. Okay, so let's start with the lineage. DeepSeek has shipped roughly 7 vision-related models in the last 24 months. Back in March of 2024, they put out DeepSeek VL. It was a small, modest 1.3 and 7 billion parameter models. They were using hybrid Siglip and SAM encoder, which was nothing flashy at the time, but it set the foundation. Then in October 2024, they released Janus. This one mattered architecturally. They decoupled the visual encoder for understanding versus generation. Most unified multimodal model at the time had this single encoder bottleneck where the model was forced to compromise. Janus basically said no, and the idea was to run 2 encoders but share the transformer. In December 2024, they released a second version of their vision language model. This is where the efficiency story really starts, as with the other DeepSeek models. They ported mixture of expert and multi-head latent attention from V2 and V3 into vision. A tiny version had only 1 billion activated parameters, but it was scoring 809 on OCR bench and 88.9 on doc visual QA. These were small activations with really big numbers. And that's kind of the pattern of DeepSeek released models. Then in January 2025, they released Janus Pro 7B. Now, this one went viral because it landed during the R1 moment. And it had some really awesome eval numbers. On Gen eval, it was 80%, beating DALI 3 at. And the main thing was that you could run this model on a single consumer GPU. But the real breakthrough was October 2025, when they released DeepSeek OCR. This is the first version. And the framing was strange because they called it OCR, but it really wasn't. The actual idea was that take 1,000 text tokens, render them as an image, encode the image, and you get back 100 vision tokens that encode to the original text at 97% accuracy, which is 10 times compression on long context. And Karpathy reacted to it like this, quote, "The tokenizer must go. Pixel may be better inputs to language models than text," end quote. That's a moment a lot of people started talking about DeepSeek Vision Team seriously. So if you ask what the through line is across all these models, it's basically one question. What's the cheapest representation that still works? So VL2 said fewer activated parameters, In Janus, they said decouple the encoders. In the OCR paper, they said compress text into pixels. And this paper says make special coordinates first-class tokens in the chain of thought. Okay, so let's get into what the paper is actually arguing. There are two gaps in the current multimodal models. The first one is the perception gap. The model cannot see finer details. Most of the work in 2024 and 2026 was on this. High resolution cropping, dynamic patching, thinking with images. That's all about seeing better. And we have seen some example from frontier labs, like with the nano banana models, with the open AI image generation models. But the DeepSeek team is arguing that there is a second, more fundamental gap they call the reference gap. Even when the model sees perfectly, language is too imprecise to point. Think about it like this. If I ask you which one is the third bear from the left on the rocky ledge, you can describe it in words, but you will lose track of which entity you are actually talking about as your reasoning gets longer. Now, humans solve this with finger gestures. Models until now didn't have that equivalent. So here is what they actually do. The user asks, count the number of men in this image. It's a team photo. It's very dense. So instead of the model just trying to count in language and confusing itself, the model writes out mid-thoughts the bounding boxes of every person it identifies. Every single person has a coordinate, and the format is just inline tokens. The model literally outputs a reference tag with a label, followed by a box tag with two corner coordinates. These are special tokens in the model's vocabulary. It's not function calling. It's not a separate tool. It's part of the chain of thought. You can actually see why this is really, really powerful idea. Counting in dense scenes, multi-hop spatial reasoning, and even the famous Chihuahua versus Muffin meme, it all becomes more reliable when the model can literally point to things. All right, so let's look at how the model is built, because the efficiency angle is genuinely impressive, as with other DeepSeek models. The base architecture is pretty standard. Image goes into a vision transformer, text goes into a tokenizer, both feed into large language model. And there is a detokenizer on the output side. The interesting part is the choices they made. The language backbone is DeepSeek v4 Flash, which is the smaller of the two v4 variants that were released. And we're talking about 284 billion parameter mixture of expert with 13 billion active parameters. So you're getting frontier grade reasoning, but only paying for 13 billion parameters at inference. And this vision or visual encoder is where the efficiency story really shows up. They built their own vision transformer from scratch called a DeepSeek Vision Transformer that supports arbitrary resolution. It uses 14 by 14 patches. So 756 by 756 image, you're going to get about 571,000 pixels. First becomes 2,916 patch tokens. Then they apply a 3x3 special compression along the channel dimension, taking 9 adjacent patches into one. That brings it down to about 324 tokens. And then their compressed sparse attention mechanism, which is from the V4 paper, compresses the KV cache by another factor of 4 and results only 81 entries in the KV cache for the image. Pixel do a KV cache entry, that's about a 7,000 times compression ratio. Now, I think this is the real story in this whole model release. They're not just shipping a vision model, they are shipping a vision model that costs roughly a tenth of what every other frontier model costs to run on the same image. And that's kind of crazy. Now, the training pipeline is also worth a quick look because it's one of the more elegant designs I probably have seen recently. There are 5 different stages: pre-training on trillions of multimodal tokens, then specialized supervised fine-tuning where they train 2 separate models, one for thinking with grounding using boxes, one for thinking with pointing using points. Then specialized RL with GRPO on each with 3 reward heads. And these are format, quality, and accuracy. Then a unified RFD that merges them. And finally, on policy distillation into a single student model. So basically, they are training 2 specialists and then consolidating them. Okay, so let's talk about the benchmarks because this is where I want to be careful. The most impressive numbers are on topological reasoning. On the maze navigation benchmark, they constructed this model scores about 67% against 49% for Gemini 3 Flash, 50% for GPT 5.4, 80 or 49% for Sonnet 4.6. And if you look at it, that's almost 17 points gap over GPT. Now for patch tracing, it's a very similar story. You're looking at almost double the score on the lowest competitor. On counting and special reasoning, they win some, they tie some. Gemini Flash 3 is still ahead on raw count QA, but the topological tasks, maze path tracing, those are exactly the tasks where you would expect pointing to help because the language is uniquely bad at trajectory descriptions. Now, I want to flag something. The paper is honest about it, but a lot of coverage will skip it. There is a footnote that says the reported scores cover only a subset of evaluation dimensions that were directly relevant to the research focus of this paper and are therefore not indicative of the model's overall capabilities. So they are not claiming this beats GPT 5.4 across the board. They are claiming it beats GPT 5.4 on visually grounded reasoning tasks. That's a more honest claim. I really appreciate they put it in the paper. And to be honest, overall, I think DeepSeek does a much better job at honesty than compared to some of the other model providers because they always point out their limitations. There are also 3 limitations they admit. First, the model is resolution bound, so fine-grained scenes can still trip it up. Second, the visual primitives mode currently has to be triggered explicitly. The model doesn't auto-decide when to use it yet. And third, the point-based topological reasoning, the maze stuff doesn't generate well across, doesn't generalize well across scenarios. So it's not magic, but the direction is really interesting. And here's the timing piece. April 29, DeepSeek started rolling out vision mode in the app and on the web, at least a limited test along their fast and expert modes. So while the paper itself is hard to find right now, the model behind it appears to be in graying rollout. I don't have access to it yet, but hopefully they are going to release it more widely pretty soon. Now, the bigger story here, honestly, is what's underneath this model, and that is DeepSeek v4 Flash. The paper cites v4 as reference number 3, highly efficient million token context intelligence. Okay, so that's where we're going to wrap it up today. I hope you found this useful. Do let me know in the comments if you would use a model like this when it becomes available. Anyways, thanks for watching, and as always, see you in the next one.